Hello, grade 10. How are you today? Hope you're doing well. So today, in this video, I'm gonna continue our study about electricity, okay? In this video specifically, we are gonna talk about static electricity. We have two main fields of study of electricity. It will depend on the type of charge that we are gonna study, okay? Because if the charge is from insulated materials, it's gonna behave different from those charges in circuits, okay? For example, insulated charges, we call this static electricity. Is the charge that comes from insulated charge. For example, when you rub a balloon with a piece of cloth, for example, you create this static electricity. But it's different from a circuit. When it's a circuit, we call it dynamic electricity, okay? In this video, we are gonna focus on static electricity, okay? Or the behavior of insulated charges. In the next video, we are gonna talk about dynamic electricity. So what is the static electricity? Static comes from the Greek word that means causing to stand, okay? So static electricity describes all the phenomena related to insulated charge, which are usually immobile, okay? So it's charge that are usually not is not moving. They are usually immobile and deals with electrical phenomena related to insulated charge. So remember that static electricity always comes from insulated charge, usually immobile, so doesn't move much. Here there is an experiment for us to understand how it works. If you take this instrument, we call this a leaf electroscope. This leaf electroscope, we can not measure, but understand the behavior of charges. So here, for example, I have this leaf electroscope with no charge at all. So the foil, the aluminum foil that we have here on the bottle, as you can see, we have two foils. They can separate from each other. But in this, if you have this neutral, it's gonna be closed. It's gonna be closed. So if I have an uncharged electroscope, the foil will be together, be close by. But what happens when I have a charge? For example, if I have this electroscope here and I touch a conductor, for example, with negative charge here. Okay, so I have this with negative charge touching this metal knob on the electroscope. So touching the metal knob. What's gonna happen? If here I have a negative charge, what kind of charge will the metal knob will attract? Which charge is gonna be here? Remember, negative will attract which charge? Positive, right? If I attract positive here, what happens to the negative charge of this electroscope? Where does it go? If it not attracts, it's gonna be repelled, so it's go away. So while the positive comes here, the negative goes further, okay, as much further as possible. And in the aluminum foil, sorry, what's gonna happen? I'm gonna have a lot of negative charge here from both foils of aluminum. If I have a negative charge in one side and also negative charge on the other side, what's gonna happen to these two foils of aluminum? They are going to repel each other, they're going to separate. So that's why this aluminum foil will open when I have negative charge concentrated here because they repel each other, okay? Now, what if instead of I touch a negative conductor, I touch a positive conductor? So now I have positive charge here touching. What kind of charge will attract to the metal knob? What kind of charge will be here? The negative charge. Very good. So the positive will attract the negative charge. And what's going to happen to the positive charge? If they are not attract, they're going to repel. So they go as further as possible. So they go here, further as possible. All the positive charge will concentrate here. If I have positive charge in both foils of aluminum, what's going to happen to them? They're gonna also separate because I have the same charge in both foils of aluminum, so they're gonna separate. So doesn't matter if I touch a negative or a positive conductor, the behavior of aluminum foil will be the same. But remember that it depends on the charge here that you can predict the charge that you have below. Okay, so if I have a charged electroscope, what's happened? My foil goes separate. So my foil separate. If I have uncharged electroscope, my foil goes together. If I have charged electroscope, my foil goes separate. And the charge will depend on the charge that I touch here on my first conductor. Okay? Okay, so if I have objects that are charged, they usually do not remain permanently charged, okay? Because they usually uh, lose their charge by combining, for example, with other molecules from air. So that's why static electricity is less frequent during humid weather. Okay, so for example, during spring when it rains a lot, we usually experience less this kind of spark that we feel than during cold weathers. Okay, we can observe, for example, if you dry your clothes when you take it out from the dryer, you can feel a lot of static electricity, right? Have you ever feel that? Why does it happen? Because I removed the water. So if the less water I have, more static electricity I'm gonna have because cause the tendency to stick together dry clothes. So the electricity from the dry clothes will cause them to stick together, okay? Because I have less water. But of course, with time, this static electricity is gonna lose their charge, then it's not gonna stick so much after some time because it's gonna combine with the water from there, for example. Another property is that charged objects make recover their natural state very quickly. Okay, when two objects of opposite charge come close to each other, so they are gonna recover this neutral when they touch each other. We call this electrostatic discharge. For example, it's always accompanied by a spark. So electrons pass through the air and hit it, make it light up. This is what happens, for example, when you have a storm. The lightning bolt involves the rapid neutralization of two charged objects, the cloud and the ground. So what's happening here? Two objects, in this case, the cloud and the ground, when they touch each other or when they come close to each other, they make they make the rapid neutralization of their charges. So the charges pass through from the cloud to the ground. And we can observe this like discharge by this lightning bolt. Okay, so we call this electrostatic discharge when they quickly recover their neutral state. So by quickly transferring the charge from the cloud to the ground, they quickly recover their neutral state. And then this is usually accompanied by a spark. Okay, now how do I charge an object? We have three ways of charging an object: friction, conduction, and induction. Okay, we are going to talk about each of them now. For friction, friction happens when electrons are whipped out from one object to another. So I take the electrons from one object and transfer to another one. This happens when I have two neutral objects and I rub them against each other. Okay, so when you take two objects and rub them. When you rub them, what happens? The electrons from one object go from one object to another object. So transfer objects from one to the other. This results in two bodies with opposite charges. So when I take the electrons from one object and pass to the other, the result is two bodies with opposite charges. So for example here, I'm rubbing a glass rod, so a glass rod with a piece of silk, okay? If I rub this, what's gonna happen? The silk atoms pull some electrons away from the glass atom. So the silk is gonna take it out the electrons from the glass rod. What's gonna happen? The glass rod will be positive because it's lost electrons, and the silk will be negative because it receive electrons. So remember, to become positive doesn't mean I take protons. No, what changes is just the electrons. For me to be positive, it means I lost electrons. Okay, so in this case, the glass becomes positive because it lost electrons, and the silk becomes negative. Okay, but now that you can ask me, how do I know which object will lose electrons and which object will receive electrons? To answer this question, we have a chart that we can use because it depends on the tendency of the materials to capture or to give up electrons. Each material has its own property of capture or give up electrons. So some materials give away electrons more easily, and some materials attract electrons more easily. For us to know which or what the material was going to happen to that material, we have a chart that we call triboelectric series that provides a list of the ability of materials to capture or to give up electrons. So here is the chart, okay? You don't need to memorize this, you just need to understand. But for example, here, the more positive materials, it means it's gonna lose electrons more easily. And in the opposite, in the negative part, it means these objects will be attracting more electrons. So for as much positive it is, it means it has more facility to give away the electrons. And negative, it means it's gonna lose the electrons. So the positive charge means what? High tendency to give up electrons. So it's gonna lose the electrons. So more positive is gonna lose easily the electrons. And more negative, it means it's gonna have high affinity for capturing electrons. It's gonna receive more electrons. It's gonna take it out the electrons more easily. It's gonna attract more electrons. Okay. So to practice, let's do an example. So here, if an aluminum foil is rubbed against a t-shirt made up of polyester, which one will have positive and which one is going to have negative charge? So according to this charge here, I have the aluminum here and the other material is polyester. If I rub each other, what do you predict between them? What is the property of aluminum? Aluminum, compared with polyester, aluminum give up electrons or receive electrons. So according to this charge, aluminum is giving up electrons. What about the polyester? Polyester is attracting electrons, is receiving, is capturing electrons. Okay, so if aluminum wants to give up electrons and polyester wants to capture that electron, which one is going to be positive charge and which one is going to be negative charge? What do you think? Aluminum will be positive. Why? Because it's gonna give up electrons. So aluminum will become positive charge. What about polyester? If polyester receive electrons, it's gonna be negative charge. Okay, so according to this triboelectric series here, we can predict which material will become positive and which material will become negative. Okay, let's do another example just to fix this concept. If an aluminum foil is rubbed against a glass rod, which one will have positive and which one will have negative charge? So here I have two kinds of material. The same aluminum, but now I'm rubbed against the glass. Okay? Okay, now let's observe. Glass has what both of them wants to do. Glass wants to give away electrons, but aluminum also wants to give away. So aluminum has a high tendency of give up electrons, but the glass also have a high tendency of giving up electrons. So now how do I decide? Which one is going to be positive, which one is going to be negative? Now we need to compare both of them, okay? Who is going to give and who is going to receive electrons? Glass has a higher tendency to give up electrons than aluminum. If you observe in this chart, glass is above aluminum. It means glass has even more tendency to give up electrons. It means glass hold their electrons weakly when we compare to aluminum. So glass have a higher tendency to give up electron. So if they are competing between the electrons, aluminum hold the electrons more strongly. So aluminum hold better the electrons. So it means glass will give away the electrons more easily, while the aluminum will hold it. Because glass will give away more easily, it becomes positive. Why? Because it will lose the electrons for the aluminum. So in the competition, glass will lose electrons, and the aluminum will receive the electrons. So aluminum will be negative. Okay, so I put this example here for you to observe that you cannot just memorize this chart. You need to understand. Because if I put the same substance, for example, in the example 1 and 2, I'm using aluminum, but I'm comparing with different other materials. So aluminum will behave different from all the these materials that above. For the materials that have above, aluminum will be negative, will receive electrons. But for all those below, it's gonna give away his electrons. And this works for any material of this list, okay? So when doing exercise, you need to check this series. You don't need to memorize, but it's gonna be available for you, but you need to understand how to use it, okay? Is that fine? Okay, let's move on. Now we are talking about friction. Now we're gonna talk about conduction. So conduction happens when electrons move from one object to another by direct contact. So I touch each other or I create a spark. So it's like a quick movement of electrons. In this case, I already have two electrically charged electrons and they share their charge between them. Okay, so they are already charged. They have already charge, but then when they touch each other, they share this charge. What's gonna result? It's gonna result in two bodies with the same charge, but weaker than of the original object. This is the same logic for temperature, for example. If you put, for example, one object that is hot with another one that is cold, they both has this temperature, cold and hot. But when you touch them, what's gonna happen? They're gonna make the equilibrium. The hot will become colder and the colder will become hotter, right? So they're gonna not be so cold or so hot, but they're gonna be in the middle. Okay, so they're gonna be warm. This is the same here. If I have a positive charge together with a negative charge, they are gonna be sharing the electrons and they're gonna be in equilibrium after. So for example, I have a neutral conductor here and I touch a negative cylindrical rod full of negative charge. What's gonna happen here? If I have more negative charge, it means all the electrons will pass through the neutral spherical conductor. And what's gonna happen? The rod will lose some electrons and the neutral spherical will receive some of these electrons. In the end, both of them will have the same charge with but with weaker force than it was before. It's like hot and cold. Okay, it's gonna be both of them will be warm. Warmer in this case is gonna be in the same with the equilibrium quantity of charge. This is conductor. Okay. The last one is induction. So it happens when charge in an uncharged metal object change without direct contact. So different from the previous two, friction and contact, we don't have a contact. I don't have a direct contact. This is an example, for example, when you have a comb and pieces of paper. Have you ever tried this? So you can take a comb and rub in your hair and then try to touch some piece of paper to see what happens. So through induction, the comb that's gonna be charged, okay, is gonna attract some piece of paper that's gonna be neutral. Okay, so this is induction. Why? Because you don't need to touch the paper. You can just make this a little closer, but without touching, the paper will stick to the comb. Okay. So for induction, how do I test it? If I have, for example, a charged object A and a neutral object B, I don't touch it, but I put them close. What's gonna happen? Opposite charge will gradually accumulate on the side of B that's facing the A. B will return to its natural state or insulated or carry opposite charge of A or conduct. So there is two situations that can happen here. Okay, let's explain with an illustration. If I have a neutral object here, B, and I touch a negative charge object A, what's going to happen to this neutral B? What's going to happen? If this A has negative charge, it will attract all the positive charge of B for that side. So all the positive charge will go close by the negative charge of A, okay, because opposite attract. And the opposite, the negative, wants to go away. So it's going to repel the negative, so goes away to the other side of B. So what's going to happen? The B, the opposite charge will go closer to that conductor, in this case is A, and the same charge will go away. If the object B is insulated, okay, remember what's insulated materials. If B is an insulated material, if I remove the A, the B will return to its natural state. Okay, so if I remove the A, the B is gonna be neutral again. But this is different if my B is a conductor. So if my B is a conductor material, what's gonna happen? The charge will be transferred to the conductor attached to B. So IB is a conductor and it is attached to another material here. what's gonna happen? The negative charge that was in the opposite side will go away with that other conductor that is attached to B. So even though I take it out the A, the B will not return to its natural state because it has lost the negative charges. Okay? Okay, so finally, let's summarize everything here in a chart, okay? So per method, friction, conduction, and induction, and let's compare what happens before, during, and after. So first, friction. Before, what I have? Before I have two neutral objects. So I have two objects that are neutral. I don't have any charge. But if I rub them, what's gonna happen? Electrons will pull away from one of the objects and transfer to another. How do I know which electron will receive? Which material is gonna receive electrons? Which material is gonna give away the electrons? It will depend on the type of material. Then we take a look in the triboelectric series. So after, what's gonna happen? I'm gonna create two objects with opposite charge. So before it was two neutral, now I have two with opposite charge. Okay, which one is positive, which one is negative? It depends on the material you are checking. Okay, conduction. Conduction, what I have before? I have one charge and one neutral object. Okay, so one charge, let's say positive, but can be negative as well. Okay, so I just represent the positive here. What's important is I have one charge and the other is neutral. What's happened during? So if I touch each other, the charge of one of the objects is shared between the two objects when they come into contact until they receive an equilibrium. So in this case, let's say I have two charges only and the other one has no charge at all. What's going to happen? They're going to be with like charge. So they're going to share until they have the equilibrium. So the final, they're going to have the same charge sharing equally between the two of them. And finally, induction. What do I have? I have also one charge and one neutral. Okay, so I also have one charge and one neutral. And what's gonna happen? When I put them close by, the charge object cause the charge in the neutral object to separate. So I separate the charge in the neutral objects. And what's gonna happen? One charge object and the other with opposite charge separated. So here, if I touch a positive one, a negative charge will be close by that positive charge, and the positive charge will go away from that positive charge because they repel each other. And then it depends if this second object is insulated. If I remove the first charge that was touching, that was close by, it's gonna return to its neutral. But if the B is conductor, when I remove, he's gonna lose some positive charge in this case, and then it's gonna not return to its state, this original state. Okay, so that's it for today. Thank you so much for watching, and please do the exercise. Okay, thank you so much and have a great day.